Bismillahirrahmanirrahim. I am going to tell you about this normal distribution. Okay. When you see, whenever I teach you, tell you about anything, I go a little bit back. Before this, you have studied about the binomial distribution. And you know that there was a way of writing this. We used to write this that X is binomially distributed with the parameters n and p. And then you have studied about the geometric distribution, and you used to write it as that y is geometrically distributed with the parameter p, and that p was given there. For the binomial distribution, we must be aware of n and p. Similarly, when you have the normal distribution, we write it like this, that this z is normally distributed. I shouldn't be using this z here. Anyhow, there's a special significance of this z in this normal distribution. Anyhow, since I have used x and y here, so I'm just using this z. So this is going to be the mu and the variance. So these are the parameters of a normal distribution. So first of all, the way we write it, what are the parameters of a normal distribution? Then I'll be comparing this with a little bit with the binomial distribution, and then we'll go deeper into this new concept, the normal distribution. Uh, One of the differences between the normal distribution and the binomial distribution is that here, this n is very important. Like you must know when you have to find that what is the number of heads in a particular experiment where you're tossing a coin. So let's say you say what's the probability that you get 3 heads. You must be knowing that how many times you are tossing this coin. So this n, that is the number of trials that should be known. Okay. Then uh, in this normal distribution, this n has no significance. Like, in fact, you will not hear about this n. Okay, na? So this is going to be totally insignificant here. Okay? This n is not going to be any more significant in case of a normal distribution. Now, the second, you will know more about this. Just be a little bit patient here. Okay. The next difference is that binomial distribution and both these geometric distribution as well, they their business is totally in the deal in the discrete data. Okay, we cannot say that we have 2.5 heads when we are tossing a coin 5 times. We're having 3.68 sixes. Okay, na? So this does not happen in this binomial distribution. We totally deal in the discrete data. The normal distribution is totally opposite to it. We totally deal in the continuous data when we are going to study this. We're going to solve problems on this normal distribution. So this n is insignificant here. We have to have the continuous data. Okay. And then now let me focus on this normal distribution. I was comparing this with the binomial distribution. And one more thing is, what do we find when we have the normal distribution? When you had the binomial distribution, you were actually finding the number of times the success is happening. That was your R, what it was representing. In your geometrical distribution, for example, if you define probability x equal to 4, so you're going to find that probability when your success is going to happen first time on the 4th trial. Okay? This tells us that in a given, for example, you're doing something 5 times. So what is the probability of 3 successes out of 5 trials? Okay. But here, this is totally different. Since you're dealing with the continuous data, so if you have something like this, probability x is less than r, so you're going to find the probability for something to be less than r. And one more very important difference that I forgot to mention here, that um, here this was very significant if you have probability x is less than 3, or you have probability x is less than or equal to 3. Okay, because you are dealing in the discrete data. Here, if you have less than sign or less than or equal to sign, there is no problem with that. Okay, so it has no impact on your answer if you have the less than sign or you have the less than or equal sign here. Okay, I said there was one difference that was I forgot to mention, that in your binomial distribution and geometric distributions, you have just two kinds of events. You have success or the failure. Okay, but there's no binding about this. No limit onto this normal distribution. So, like your data can vary throughout. There can be a number of different outcomes over here, not just the head or tail, or like six or not a six, not like that. Okay, so though we can always divide our data into two segments, but this will not be the case here, that we are not going to study only about two things. Okay, now coming to the point, that why do we call this normal distribution a normal distribution? Now guys, listen, suppose I give you a test. Okay, and the test was out of 30 marks. Okay, the maximum marks were 30. Okay, now this was an online test, and all of you are getting 30 marks. Everyone is getting 30 marks. So is that a normal phenomena or an abnormal thing happening here? Yes, guys.
Abnormal.
It
Normal,
is an
sir.
abnormal thing happening here. So we cannot keep this test as a part of your like monthly or annual assessment. Okay. Similarly, there is another test after the break. You came back to the school. Okay, and then I give you another test of 30 marks, and all of you are getting a 0. Okay. Now, is that a normal phenomena or an abnormal phenomena?
Abnormal.
Abnormal.
Again, this is abnormal. Okay, so we call this normal because you see, again, let me give you some more examples. Suppose I ask you that, okay, go out and pluck a branch from the tree. Okay, and then measure the lengths of the leaves of whatever that tree was. Okay, suppose that was a mango tree, and you got a number of leaves, I mean, removed from that branch. Okay, so is it possible that all the leaves, they have the exact same length? Hmm?
No, it's not possible.
This is not possible, Hannah. This is not possible. So if you see that, oh, all the leaves, they are having the same length, so this is something abnormal. Can you can you remember any event where you went onto a marriage, or like on marriage wedding party, or like you went into any kind of a gathering and you saw all the people there with the same height? Hmm? Naina.
No, sir.
So these are the abnormal things. So naturally, when the things happen, so you have already named that bell-shaped curve. Okay. So this is what happens normally if I draw this properly here. Okay. So the majority of the people, they are clustered over here. Okay. And there are very few people who are scoring very high. Okay. There are very few people who are scoring very low. Okay, the majority is found here in the middle part of this curve over here. Okay, so normally when our data is normally distributed, so we have, let me give you its actual information now. Okay, if you have a curve like this, by the way, this curve is obtained through a histogram. The further mass people know more about this, that they have studied the probability density functions there. So we draw a histogram with very small class widths, okay? And then we draw it in such a way that the total area under this curve is going to be 1, okay? And there is a proper procedure for that. So now imagine that the total area under this curve is going to be 1. And when I say 1, so why we want this total area to be 1, bacho? Hmm?
because probabilities add up to
Yeah, the
1.
sum of the
Obviously.
probability in any experiment, that is going to be 1, okay? So we keep the area under this as 1, okay? Now a normal distribution has the same mean, median, and mode. This is the mu over here, that is the mean over here, okay? Acha. Um, Before I go into that, let me show you, we mainly have three kinds of curves, okay? Now this is, they can be a curve like this, and then there can be a curve, sorry, let's say, let me draw a 1 second. We can have a curve like this, okay? And then we have a curve like this, okay? Now, if this is the mean over here, you see that there are more values before the mean. So this is, okay, I was telling you that this is like if this is the mean over here, so there are more values before the mean. So this is negatively skewed data, okay? And here, if this is the mean over here, then you see that there are more observations after the mean. So that means this is going to be a positively skewed data over here, okay? This one is evenly poised data over here. So there's an equal number of observations before the mean and then after the mean, okay? Acha. Now suppose if I have taken a test and out of 30 marks and your average marks are, suppose the class average is 22, okay? And then there is a standard deviation of, let's say, 2. We calculated the standard deviation, that is 2. So we have 24 here, we have 20 here, we have 26 here, we have 18 here, we have 28 here, and we have 16 over here. Now, this is one of the features of a normal distribution, that nearly two-thirds of the class will have the marks between 20 and 24. Now, this is written as the probability that your x is between mu minus 1 standard deviation and mu plus 1 standard deviation, because your mu is 22. So 22 minus 2 is 20 and 22 plus 2 is 24. That is approximately equal to 2 by 3. So if my class marks, they are normally distributed, then two-thirds of the class that will have the marks between 20 and 24. Then if you want to see that how many people have scored within 2 standard deviations, so that is mu minus 2 standard deviations and mu plus 2 standard deviations. So if it is a normal distribution, then nearly 95% of the class will have the marks between these limits over here, okay? 95% class के marks would be between 18 and 26, okay? So this is approximately 95%. And again, if it is a normal distribution, then nearly all my class will have marks within the 3 standard deviations from the mean. Okay, so nearly all the class will have, like, this is going to be all your 100% of it. This is approximately 100%. All the class will have the marks between 16 and 28. So that is how this behaves. Okay, acha. Then if we go ahead, तो इसमें होता है कि this is basically uh, probability density function, okay? And we have kept its total area under this, that is going to be uh, 1, okay? So this was 22 here, this was 24 here, this was 26 here, this was 28 here, this was 20, this was 18, and this was 16. Okay. So how we will be dealing with the problems over here, you will be asked a question, okay, find the probability that uh, a student has marked less than 27. The marks per student are less than 27. Okay. So आप क्या करोगे? You will say, okay, here I have 27. So all of this area is going to uh, tell us the probability that the marks are less than 27. Okay. If we are going to find the probability that X is, let's say, less than 18. Okay. Now there's no significance of this equal mark over here. So less than or equal to 18 would be that there is a very less chance for someone to have marks less than 18. Okay. Similarly, if someone says, okay, what's the probability that your marks are between 20 and 23 maybe? So, here you have 23 and here you have 20. So this area is basically representing uh, this probability. And the further maths people, they have learned how to find this area through the integration as well. Okay. So uh, I have given you an introduction to this normal distribution. Now I'll take you to the next segment where I'll tell you how to read, how to find the probabilities from a standard normal distribution table. Okay. So please come back for the second session with us.